The purpose of this educational software is to help the student understand what's the meaning of linear transformation, what it can do and what it can't do. Let's see. We can just add a vector and another vector. And here we have a matrix of a transformation. Here it's just a matrix that makes a extension. So if we just apply it several times, we see it extension. If we'll put it, we'll put different values, we'll get like a shrink matrix, something like that. We can also do something like this and see what's going on, and something like that. We can add many other vectors and see what's going to them. And what we can also do is draw lines between vectors, something like that. Just a minute, we have to see them. And a line like that, and a line like that, for instance. And that now, when we apply the transformation, we can see what's going on to our drawing. We can also choose not to show the vector at all, something like that, or to see the vector just as dots, something like that. Okay. Let's add some more to our painting, something like that. I don't know. Draw. What shall we draw? Maybe something like a dog. Here. This is his eye. I don't know if it's clear. This is the head of a dog. One foot. Another foot. The body. Another foot. Another foot. And a tail. And something like that. This is the dog. Let's choose not to see the dot. This is my dog. I can still make the transportation or transformation. Here, something like that. Apply transformation. Okay. So we also have some pre-prepared matrices. Like this is a matrix of rotation. We can put here any expression. Let's apply it. We see that our dog is being rotated. We can also make it rotation and shrinking, something like that. Okay, now, oops, what? It's a great shrink, and we also have some preprepared rotate and enlarge. Let's see how that's going. Okay, this is our dog growing. We can save the dog whenever we want. Dog VGR for vector graph. Okay, now we can clear. We can also load another file that we've done before, like this is a witch. Let's shrink it. Okay, again we can see a vector representation of it, which is maybe not very useful right now. Very big. Okay, now let's do something simpler. We'll just we don't want to see the axis. We don't want to see the edges. We want to see the axis. Yeah, we want to see it. And now we want to see only errors. Okay, now we'll just add two vectors like that, and apply transform. Okay, now we want to see the future, where it is heading to in the next transformation. Here just move like that, but if we'll do something like revert. Okay, after applying this matrix, this vector will move to here and this vector will move to here. Let's see. Okay, and if we'll do something like rotate and enlarge, this vector will move here, this vector will move here. Let's apply it. Okay, we can also see the past, like what happened. Okay, now we see all the things that had happened to the vectors. Something like let's make it revert, or this kind of revert, and now again rotation. We see everything that happened. Actually, if we think about it, the beginning of this trail and the end is the composition or multiplication 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 of all the matrices, the transformation matrix until now. Well, that's about it. Yes.